Hello everyone. Today I am going to talk about machine learning or ML for short. So machine learning is a part of artificial intelligence, the AI. It helps computers learn from data and make decisions without being told exactly what to do every time. So in 1959, a scientist named Arthur Samuel said that machine learning is the ability of computers to learn without being directly programmed. This means that we don't have to write step by step instructions. The computer learns from examples and improves by itself. So it's something like analyzing the data and recognizing patterns. The ML models can make predictions and improve in overtime. Let me talk about the history of machine learning. Long, long ago, the people had idea that computers could learn from the data. Over time, scientists made better algorithms, or you can call them as steps, that could improve on their own. When we got big data and faster computers, machine learning became more powerful. And now, in this modern era, the deep learning and AI systems can do amazing things like understanding images by pixels, understanding the text and speeches. Now, there are like three types of machine learnings: the supervised, unsupervised, and the reinforcement. The supervised learning is like we give the machine the data with answers. For example, is the email spam or not? So it's something like when it comes to the supervised learning, the label data is mainly considered. And unsupervised learning, it's like the machine finds patterns in data without answers. For example, grouping customers into types. So unsupervised learning takes an unlabeled data where it follows the patterns. And when it comes to the last, reinforcement learning, the machine learns by doing something and getting reward or punishments. For example, a robot learning to walk. So these three are the machine learning models, and there are some of in it. So regression model, decision trees, classification techniques, neural networks and deep learning, and clustering methods. Let's look at some. Regression, it's like predicting numbers, like predicting prices. Classification, it's like putting things into categories. Example, classifying animals, classifying emails, classifying a breed of dogs. And when it comes to the decision trees, it's like a rule based model, which goes like an if condition. If it is true, then it goes to one path, and if it is false, then it goes to the other path. And when it comes to the neural networks and deep learning, these are like a small brain for computer, very useful for images, text, and speech recognition. And clustering methods are like anomaly detections, grouping the data and finding the outliers. So these are the key algorithms in machine learning which comes under those three different models of learnings. And last, the challenges which are faced in machine learning. Even though machine learning is powerful, there are some problems with it. High quality datasets are essential for ML models. That's true. But bad data gives bad results, which gives a negative impact on performance. And overfitting, when the model remembers the training data too well but still fails on the new data, leading to poor real world performance. And interpretability, it's something like models like deep learning are hard to explain, making difficult for the understanding and the decision making process. And ethical concerns, where the machine learning can be unfair if the data is biased. So we must build a responsible systems for it. Now, let me show you the Google Colab Notebook where I have added some extra explanations and pictures. So this is the AI timeline where at first the AI was just an idea of making machines to think. Then we had narrow AI, where the systems that do one task well, like playing chess. Now we are getting closer to general AI, where the machines can do many tasks. So in the timeline, we can observe that the birth of AI is started at somewhere between 1950 to 1960, and focusing on specific intelligence started around 1980 to 1990, and there it goes to the specific problems, the machine learning where we are currently l- learning with the high speed networks from the 2010. So the first definition, as I said you before, ML is where computers learn by themselves instead of being told what to do. This is the main idea behind the entire machine learning. And when it comes to machine learning, let me say in a nutshell, this is a set of techniques. It's like identifying things like objects in a photo, classifying emails or messages, predicting trends like future sales, and where even though it's having fed into many systems, the results are getting better, performance improving. This entire thing is known as statistical learning, but it's not equal to classical programming. Let me show you the difference in the picture. In classical programming, we can observe that we will give the input with set of rules and data, and the output is the result. And when it comes to machine learning, we'll give the input of data and results, where the outcome is rules. So this is how the machine learning is differ than the classical programming. Now, the machine learning workflow. This is how ML works step by step. It defines the problem, collects and cleans the data. It chooses a model, train and test the model, tune the model to make it better, and use it in the real world. It's like deployment. And we'll keep checking and improving it. So these are the five important things which are generally known to everyone in this machine learning workflow. And when it comes to the AI versus ML versus deep learning, here's a picture like a Venn diagram. So AI is a big field which consists of sensing, reasoning, acting, and adapting. ML is a part of AI which consists of algorithms to perform. And deep learning is a part of machine learning that uses big neural networks which are hard to explain. And as I said you before, the topology of machine learning, it's consists of three things: supervised, unsupervised, and reinforcement. So here you can observe a complete graphical representation, a flowchart representation to explain entire machine learning, how these three differs. Let me go through the ML models. So first with regression. So the system predicts continuous values like example temperature forecasting, asset price prediction, and etc. Here in this diagram or the picture, you can see that how many cups of coffee sold and time of day in hours. So there are three different trends which are shown: the coffee sales, linear trend, and actual trend. So regression model, it's like predicting what happens at what time. And when it comes to classification, the system predicts discrete values by the input is categorized. So you can see there are dogs and cats which are differed with symbols. Dogs are shown with plus symbol and the cats are shown with a multiple symbol. So this is how classification differs. It detects if an image is spam or not only that, it detects if the given data is separated or not by different input methods. And the classification types are three types: binary, multi-class, and multi-label. So binary is like only two possible classes. Example, cat, not cat, spam or a legit, beginning or a malignant tumor, and etc. And multi-class, it's like several mutual exclusive classes, like example, handwritten digit recognition. And when it comes to multiple label, it's like several non-mutual exclusive classes, example, face recognition, thumb recognition, hand recognition, and etc. And when it comes to the clustering, it's like grouping of customers of by any sort of thing. It's like data is partitioned into groups. You can see there are three centroids and three clusters which are divided like. So these three are different kinds of things. It's like they are grouped into three different parts. So this is how we can say. And when it comes to the anomaly detection, it's finding fraud in transactions. So you can see the system is able to detect abnormal samples of outliers, which is also given in the diagram. It's purchased this week in dollars and average purchase per week. And we can see the typical activity and possible fraud. in the diagram, where it shows the possible fraud in a triangle and typical activity in a circle. This is complete a normal structure to determine how anomaly detection is done and how do machine works with different algorithms. Let me say the k nearest neighbor, where it predicts based on the k nearest neighbor data sample. So k is something value we assume, and it shows the nearest values of the assumed data. And decision trees, as I said you before, it is completely built on some rules, and it is completely it looks like a tree like structure based on a series and questions of data. And the next algorithm is neural networks. This neural network concept is something very friendly to the machine learning, where it takes the multiple set of data which is divided into multiple layers. So each layers of loosely neurons inspired computation units that can approximately any continuous function. It can approximate, as you can see in the diagram. If the computer need to if we give the input of dog, the computer takes the input and sends it to multiple hidden data, and then it goes to the output where it predicts what kind of data is it. So these are the popular algorithms. So to finish, finally, machine learning is a fast growing technology, and it is changing how we solve and in problems of business, healthcare, education, and more. So, by learning the basics, types of ML, models, challenges, and tools, we can start building smart systems that really make a difference. So, thank you.